Okay, so this is just a video to really review what we did in class today. This is parabolas with vertices that have been translated from away from the origin. Okay, so the first page of your notes kind of has a table that gives you like the standard form of parabolas. There's two different standard forms depending on whether we're opening horizontally or opening vertically. So a vertical, I'll just write them up here. So a vertical, right, so either this guy or this guy is going to have an x squared term. So we'll see it in the form x minus h squared is equal to 4p times y minus k, where hk is our vertex. The horizontal parabola, so it'll either open right or left, is going to be y minus k squared equals 4p times x minus h. Okay, so just notice that the h always stays with the x and the k always stays with the y, because our vertex of the parabola is always going to be hk. Okay, so for this first example, we have a vertex. We could see from our equation, we have a vertex at 3, -1. All right. And whether it's opening up, down, left, or right, we see that the x is the squared term. So we know it's either up or down, and the sign of the 4p value is going to tell us whether it's up or down. Okay, so this one's going to open up because our p value is positive, right? So x is squared, and p is positive. That squared is kind of messy, but x, that's supposed to say x is squared, and p is positive. Okay, so that tells us it's up. And again, that's all in that table on the first page of your notes. Okay, so now the focus, we're going to get the focus. The 4p value is going to help us get the focus. 4p in this case is 8, which makes p equal to 2. Now keep in mind that the p value doesn't give us the coordinates. It just tells us how far away from the center, from the vertex rather, I keep saying that, how far away from the vertex the focus is, right? So this is telling us that we're 2 units away from the focus, and because we're opening up and p is positive, we know we're 2 units above the vertex. So if the vertex is here at 3, -1, the focus must be up 2 units at 3, +1. So I like to just put like a little x instead of a point, but it's really, the focus is really a point, an invisible point kind of on your parabola, right? So this means focus is 2 units above the vertex. And again, it's above in this case because we're looking at a vertical parabola that's opening up. Okay? And likewise, the directrix is p units in the other direction from the vertex, right? So this is p here, and then to get the directrix, we're just going to go 2 units in the other direction. So this is also p, and our directrix is the equation y equals -3. Okay, so now that's all that's left, is to find a couple of points on our parabola, and there's 2 ways to do it. One way would be to plug in values to the right and left. So plug in y equals 1 into our equation and find out what x equals. The other way, and personally the easier way, the shortcut, is to recognize that this 8 here, this 4p value, this 8, is the length of our focal chord, right? So if it's the length of our focal chord, if our focal chord is 8, that means we're going to have to go 4 units to the right of the focus and 4 units to the left of the focus to find 2 points on our parabola. So 1, 2, 3, 4, and 1, 2, 3, 4 here. So we have 2 points, one at -1, 1, one at 7, 1. Again, you could have found those by substituting 1 in for y and solving for x. But if you're comfortable just using that length of the focal chord, right, so we're going to kind of, I should do that in a different color. Okay, so like this length, this focal chord, is 8 units, which is the 4p value. Okay, next example. This is a situation where we have y that is squared. So we know we're going to either be in the left or the right. And we're going to determine that by, again, the sign of the 4p value. 4p in this case is negative. So that means we're going to be opening left. All right, so we're opening left. Our vertex in this case doesn't look like we have an h value, so it must be 0. Our k value is negative 2, so our vertex is at 0, negative 2. And we're opening left. Okay, so our focus, again, we're going to use that 4p value. 4p is negative 16, so p is negative 4. So this is telling us that our focus is negative 4 units from our vertex. So that means 4 units to the left of our vertex. So our focus must be here at negative 4, negative 2. And so 4 units to the left. Again, we know it's left because that's the direction that we're opening. All right, which makes the directrix must be 4 units to the right of our vertex. So that is the line x equals 4. It's hard to see it, but I did draw the dotted line there. All right, and then the only thing left is to find our 2 points. So again, if we use that focal chord, we know that it must be 16 units long because it's the same as our 4p value. So that means that if we start at the focus and go 8 in one direction, 1, 2, 3, 4, 5, 6, 7, 8, and then 8 in the other direction, we're going to go off the page. We're going to end up down here. Okay, so it looks like we have a point at negative 4, negative 10, and 4, 6, right? Because 6 and negative 10 are 8 units away from negative 2. And draw our parabola. Okay, so here's an example where we're going to have to rewrite this into standard form. I think I'm going to do it above because there's, I think, a little bit more room up there. All right, so I'm going to take these terms and move them to the other side because that's the standard form for a parabola, has y's on one side and x's on the other. So we have y squared plus 2y, I'll leave a little space for my completing the square, equals negative 12x plus 23. And if I complete the square on y, right, I'm going to need to add a 1 over here and then add a 1 over here as well. Right, so factoring, I get y plus 1 squared equals, this is negative 12x plus 24, but I know my standard form is going to have some common factor outside, so this is actually going to be negative 12 times x minus 2, right? So just process that for a second. This was negative 12x plus 24, if I simplified it, negative 12x plus 24. All I did was I factored out the negative 12, and I have x minus 2. All right, so now it's pretty clear, I think, to see that our vertex is at 2, negative 1. Again, be careful because the x's are on the right here. So remember that the x-coordinate of the vertex is always with the x. All right, so 2, negative 1. Up, down, left, or right? Well, looks like our 4p value here is negative, and we're squaring y, so we're in another left-facing situation. Right, our focus, 4p is negative 12, which makes p negative 3. So this is telling us that we're negative 3 units. Our focus is negative 3 units from our vertex. So if I move 3 units in the negative direction, I'm here. Right, I'm here at negative 1, negative 1. And my directrix is 3 units in the opposite direction. Right, and 3 units in the opposite direction from the vertex is the line x equals 5. using the focal chord length. The focal chord is 12 units long, right? That 4p value tells us the focal chord is 12 units long. So if we start at the focus and count up 6 and down 6, we're going to be at like -1, 5, and -1, -7. And we draw our parabola. Okay, and we'll finish this by doing a couple of working backwards examples. Write the standard form of the equation of each parabola, satisfying the given conditions. Now keep in mind, to write the equation of a parabola, you just need a couple of pieces of information. We need the center, the vertex. I keep doing that. We need the vertex, and we need a p-value. And again, I want to reiterate, the p-value is the distance from vertex to focus. I'm just going to abbreviate that by V and F. Right, so the p-value is the distance from the vertex to the focus. So that's all we really need, and we also need to determine whether we're squaring x or squaring y, right, and the positive or negative of that. Okay, so if we look at the first example, we should be able to tell that we're squaring x and that our p-value is going to be negative, or our 4p value rather, is going to be negative because it's upside down, right? It's the vertex is at the top, so it's an upside down parabola, and being that it's vertical, meaning opening up and down, or opening either up or down, that tells us that x is the term that's squared. Okay, so we could just start by going, well, x squared equals, leave a space for the 4p value, y. Okay, and the vertex is right there on our parabola. We can see that it's -2, 6.5, so we can kind of insert those into our formula. And then to figure out the 4p value, we're going to look at the focus and the vertex, and we're going to notice that p is equal to 2.5. Right, or really -2.5, right? Because the focus is -2.5 units from the vertex. So 4p is -10. Okay, the other way to determine that 4p value would be to look at the focal chord. Right, the focal chord is the line that goes through the focus and touches 2 points on the parabola, and we can see that that focal chord is 10 units long. So either way, either method is perfectly fine to use. So it kind of just depends on what information you have or what's easily seen on the graph. Okay, the next one is a sideways facing parabola. It's opening to the right. So that tells us our 4p value is going to be positive and that we're going to be squaring the y. Right, we can see our vertex at -2, 4. So we can go ahead and plug those numbers right. Plug those numbers right in. Y -4 squared is going to equal, we're going to leave some space for the 4p value, x plus 2. Okay, so determine that 4p value. We could look at the focal chord here, but it's kind of hard to tell because our it looks like we're going by 5s here. It's really hard to read actually on this entirely at all. So we might be better off actually plugging in the value here. Not plugging in the value, sorry, just determining, sorry, my fault. Determining the p-value, right, from the center, from the vertex to the focus. So p looks like it's 2 units, right, because the vertex is 2 units behind the focus, so the focus is 2 units to the right. So p equals 2, so 4p is going to be 8. Okay, and I mean, I guess our focal chord here must be 8 units long, but it is hard to tell with the coordinate plane the way it is. All right, the last couple examples here are again working backwards, writing the equation, but it doesn't give us a graph. So my recommendation would be to actually draw the graph, draw a quick sketch of the graph so that you know what it is you're looking at. Okay, so we're looking at a parabola that has a focus of -3, 4, that's here, and a directrix of y equals 2. Okay, so that's a horizontal line, y equals 2. Okay, so with no other information, what we can tell, because we have a horizontal directrix, is that this must be a vertical parabola, right? So a parabola where we're looking at the x term is the one that's being squared. Okay, we don't know the vertex, and we're not totally, well, we should be able to actually conclude that it's opening up, so 4p is going to be positive, because otherwise if it opened down, we would cross right over that directrix, right? So think about that, right? It must do something like this, because if we open down and that's the focus, then we're hitting the directrix, and that's not possible, right? The directrix is either, is not, it doesn't cross the graph, right? So based on what we know about a parabola, we know that the vertex is directly in between the focus and the directrix. So that must make our vertex be right here, right? Our vertex must be at -3, 3, because that's going to put us right in between our focus and our directrix, right? So we can put those numbers in here, +3, -3, and then our p-value is the distance, right? It's the distance from the focus to the vertex, and that's only 1 unit here. So 4p is going to be 4. Okay, in the second one here, we're given information about the vertex and the focus. So this one's actually a little bit easier because we're given a vertex. Okay, of 5, -2, and the focus is 7, -2. I'll make that an x instead of a point. Okay, so again, we should be able to determine that this is going to be a sideways laying parabola, and it's going to be opening to the right. How do I know that? I know that because if my vertex is here and my focus is here, my focus kind of lies inside the parabola, right? So the directrix must be back here somewhere. It's not asking me for the directrix, so we don't really care. That's not really part of our equation. We're really just being asked to write the equation, right? So all we need to know is to write the equation is it is going to be x squared or y squared, so it's going to be a y squared situation. We have our vertex, and we're going to need this p-value here, this distance here. All right, so our vertex, I'm sorry, it's a y squared situation, so y plus 2 squared is going to equal some 4p times x minus 5. Right, so we just substitute in the vertex, and the 4p, we're going to determine that p is 2 units here. Right, because the focus is 2 units away from the vertex, so 4p must be 8. And that's it.